Now, in this video, we will try to establish the equivalence of Kelvin-Planck statement and Clausius statement. So we have seen two statements of second law of thermodynamics that actually both are same. So how will you establish the equivalence? How can you make sure that both these statements are equal or one or the same? So let us try to prove that. So for this, we will consider a high temperature reservoir at TH and a low temperature reservoir at TL. And then you have a heat engine. So it takes in heat QH. Okay. And we assume that this heat engine efficiency is 100%. That means it violates Kelvin-Planck statement. Okay, that is, it is not rejecting any heat. So the W net work produced is QH. So also you have another heat pump which takes in heat QL. So you have a refrigerator working along with that, and it uses this heat from this heat engine, this work from the heat engine, that is W net, and it takes in QL and rejects QH plus QL. Okay, this is possible. This refrigerator does not violate Clausius statement. This is possible because it takes in heat QL and rejects QH plus QL by taking in a net work output. You are supplying a work. If this work is zero, that means this refrigerator violates Clausius statement. So you have two devices. You can see that a heat engine which violates Kelvin-Planck statement and a refrigerator which does not violate Clausius statement. This refrigerator is possible and this is not possible. We are trying to combine it. So what happens if you combine it? That means if you are taking these two devices together to form a single machine. See, what we are doing is that we combine these two devices. When these two devices are combined together, it will form a refrigerator. Okay, so what it is doing? It takes in heat from a high temperature reservoir QH and it takes in heat QL from a low temperature reservoir and rejects QH plus QL. Okay, so net heat transfer to this high temperature reservoir is QL only because you are taking in QH and you are supplying QH. This will get cancelled. So that means you are taking in heat QL and rejecting QL. So again I will show the high temperature reservoir. So again I am showing this combined device. So this is the same refrigerator. So what it actually doing is it takes in heat QL because I told you this will be cancelled because QH is supplied here and QH is taken here. So you can cancel it off. So this will be like this. Okay. So that means it takes in heat QL and rejects heat QL. Okay. So this is a refrigerator. So you can see that this refrigerator violates Clausius statement. Okay, this refrigerator violates Clausius statement. So we started with a device which violates Kelvin-Planck statement and a refrigerator which does not violate Clausius statement. And finally, we reached a refrigerator. We found a refrigerator which violates Clausius statement. So what we are trying to establish is, okay, here. So you have a heat engine which violates Kelvin-Planck statement. Then you have a refrigerator which does not violate Clausius statement. So we have seen that if you combine these two devices, it will violate Clausius statement. So any device which violates Kelvin-Planck statement violates Clausius statement also. Okay. This is how you establish the equivalence of Kelvin-Planck statement and Clausius statement. Okay, so you finally reached a refrigerator which violates Clausius statement.